Speaking of pliers, a real common statics problem that's in most statics textbooks is a pair of vice grips. And it's not usually on our exams, but again, since it's a common problem, let's talk about it. It's kind of like our pliers, but it just has a little bit more complex of a mechanism, and it has a two-force member here, CD. So in this particular problem, which I think is in the Hibbler book, you basically have 5-pound grip force on the grips or on the handles. And then the jaws of this vice grip apply force to this rod or this bolt at A. And we want to find the forces at these pins and the force and the applied force here. You really can't get anything from the overall free body. But once you take it apart, then it becomes a solvable problem. So if we draw, and basically, if you, and again, you can wireframe this guy. So I drew this handle pretty complex here, but you don't have to draw it that complex. You can basically draw it this way and this way. Just like that. You can later add all of the dimensionalities to it. But if you draw it just as a wire, you have a 5 out here, 5 pounds. You have the two-force member here, which is the FCD. If you look at the dimensions of this guy, this is one, I don't think I dimensioned this properly, but this is 1.75 inches, which comes from here. So you get 1 and then 0.75. So this distance is 1.75 here. And then this distance is 3. So you get 1.75 over 3. So that phi is 30.3 degrees. 30.3 degrees. And then you have pin reactions here at B. And then you have a grip force. So this top jaw is pushing on the force and pushing on the bolt until the bolt is pushing back the other way. This is FA. These bolts are at 20 degrees, and so this guy is 20 degrees from vertical. I guess we don't know the horizontal distance, but we don't know the diagonal distance, but we know the horizontal distance is 0.75 and 1.5. So this is my upper handle. And then my lower handle, again, is basically this lower guy. And we can draw him on a straight line. So the lower guy looks like this. I have 5 pounds. I have the two-force member, which is FCD at 30.3 degrees. And then I have an EY and an EX. This distance is 1 inch. And this distance is 3 inches. So if you look at this lower member, there's just 3 forces that act on him. 1, 2, or 3 components. 1, 2, 3. And so I can write a moment equation about E to get FCD. So if you sum moments about E, you get the vertical component of FCD, which is FCD sine of 30.3 degrees, times his moment arm, which is 1, and then minus 5 times 4 inches. And so FCD is 39.7 pounds. 39.7 pounds. Once you get this guy's 39.7 pounds, then we transfer him up here, 39.7 0.7 pounds. So once we get up here, we can sum moments about the pin, and we can get FA. Now this is a little trickier because this is horizontal and vertical here. And so we have to take the FA and divide him in two components. So if I'll slide this up a little bit and I'll rewrite this larger. So if we sum moments about B is equal to 0, and we're on ABD, on ABD, on this guy. And we'll take clockwise to be positive. I have 5 times 4. That's positive. Minus the vertical component of FCD. So minus FCD sine of 30.3, I'm sorry, sine of 30.3 degrees. That's a vertical component of this guy. And his moment arm is 4. And then I've got the two components of FA. So FA, I've got 0.75, 1.5, and I've got FA sine 20 and FA cosine 20. So if you take this FA and resolve him into two pieces. So both of them are going to produce a component. That's a principle of moments. The moment of a force about a point is equal to the moment of its components about a point. And so if I'm taking this way to be positive, I have a positive FA cosine 20. And his moment arm back to A is 1.5. Plus this guy. So again, he also produces a clockwise rotation. This is plus FA sine 20. And his moment arm is 0.75. And that's equal to 0. So I got two components of FA about him. And that's basically what I wrote here, except I factored out an FA. And FCD, you know, so FCD is 39.7. And we get FA is equal to 36.0 pounds. And that's the force that the jaws apply to the bolt, or that the bolt applies to the jaws. And notice we had to take the pliers apart. From the lower handle, this is you got forces just applied at the two pins right here. I'm sorry, three locations here, here, and here. But I just have 3 unknowns. And so I'm able to sum moments about E to get FCD from here. Then I transfer that up to here, and then I can sum moments here to get FA. So again, this is a classic frame or machine problem where you have to draw free body diagrams. You get a force from one free body diagram, and then transfer it over to the other one to solve what you're asked to solve. It looks super hard, but again, you can get by with a wireframe. I drew these complex, but really you can get by with a wireframe of the top jaw, a wireframe of the bottom guy, and then you don't have to worry about this part of the jaw at all, this guy here. And so it is doable, especially if you're not intimidated by it. And learn to draw free body diagrams, learn to use wireframes, learn to be careful. So that's a Vise Grip.